Hey everybody, this is Mark Smith, host of Digital Roughnecks, and I'm here with a special episode here with Jesse Fenner and Craig ONeill from FLIR, Teledyne-FLIR, and we're going to talk about Autonomous LDAR. So this is a special episode. It is sponsored by Clean Connect and Teledyne-FLIR. Now, ever since we've been working together, Craig and Jesse, I've seen this presentation from you, Craig, in particular, talking about the S-curve for technology and innovation. So why don't you, talk about your background, because I think it will help people understand how long you guys have been in this, this leak detection and repair space, and kind of where you've seen it go over the last decade or so.
Yeah, I appreciate it, Mark, and thanks for the time here. My name's Craig ONeill, and I've been with FLIR for 20 plus years and been directly involved in optical gas imaging since 2005, which you can see right there when we launched our first camera. Been a lot of changes with respect to the industry and the focus of leak detection and repair, how it fits into a environmental stewardship or safety or even regulatory practice. We've seen it, change tremendously. But one of the things that we also try to do is outside of simply trying to make the best technology for optical gas imaging for the industry and for our customers, as we continually, as you can see here, try to innovate the product. Is we try to see what's going to happen and predict what's going to happen in the future. And as we look at what's happened previously since the launch of our first camera in 2005, we've really seen some technology advancements, and we've tried to make that from going from an original camera to our GF flagship cameras to a hazardous location compliant camera, and now even with an uncooled technology and quantification, which isn't even on the curve with our QL320. But if you look at generally the way an S-curve of technology and innovation works, at some point in time, that technology, maybe it doesn't die out, but it may level off, where it may be used to kind of support other technologies and support industries without a growth pattern as far as use cases and how the industry accepts it. And as you look at, things like OGMP 2.0, some of the decisions in the existing draft rules for the US EPA, for the oil and gas industry, we really see a trend potentially in the pivot from a handheld technology where it requires an operator with an eyeball attached to it to an autonomous technology. And that's where a great partnership with Clean Connect has really been strong for the last 3 or 4 years as we look to try to enhance that potential to address that market of having a continuous optical gas imaging solution with Autonomous LDAR, and even using the technology that's approved by the US EPA, like the entire suite of our handheld cameras, but also the same detector that's in our handheld cameras is in our fixed mount G300A. So using, in essence, just replacing an eyeball behind a camera with an analytic developed by a great company like CleanConnect.ai. And that's what we don't know. You can see the question mark on there. Where does this go? Where does this next evolution of optical gas imaging go? And if it pivots to handheld, we feel as though we're in a good place. We have great partnerships. And as a technology leader, we're excited for the future of optical gas imaging as it seems to potentially transition to autonomous.
And yeah. Jesse, talk about your background too, because while you may be sort of new to FLIR, you're not new to this discussion about Autonomous LDAR.
No, not at all. Yeah, Mark, happy to be here. And to all our listeners, I'm Jesse Fenner. I'm the optical gas imaging sales manager here at FLIR for the Western United States. And I'm also heavily involved at FLIR with some of the advanced technology initiatives that we're working on, including, as the account manager for Clean Connect and working, closely with Craig and our business development team on our continuous optical gas imaging initiatives. I came into the industry in 2014 with a FLIR partner who had a solution really built around continual optical gas imaging. And what we saw at the time was a ton of excitement around the possibilities for that, right? To do autonomous leak detection, to do continuous monitoring, to fill the gaps in some of the, critical site awareness that would occur, and to help sort of prevent, the idea was to prevent catastrophic events and to sort of supplement the workforce to reduce windshield time, and to give the operators some additional awareness and some advanced solutions to help, kind of fill those gaps. And what we see now, things coming full circle, where maybe in 2014, some of that technology was a bit ahead of its time, seeing that the industry is really ready to embrace this, and is starting to adopt a solution like what Clean Connect offers through Clean Connect AI. It's very exciting to see, how far things have come, and then the potential for where things can head from here.
Excellent. Well, thanks for that background. And well, as I'm going to show real quickly, hopefully this, Clean Connect system fulfills everything that you were promising years ago, right? It's the fulfillment of a lot of those, big ideas. So I define autonomous LDAR as continuous visual AI automated leak detection, and I'll make the case for why it needs to be visual. And then AI augmented repair integrated with SCADA. So we were working on this before we hit record, talking about some of the new regulations, because Craig and I and everybody on here is really familiar with, Quado A, B, C, Appendix K, which is, the new sort of regulatory framework around the process for how you do OGI inspections. So we're looking about manual LDAR. So in Appendix K, it says, hey, every day you got to check the camera functions. Well, with the GF320, you turn it on, verify it's working. And, with our autonomous LDAR, we can check that G300A automatically every minute, make sure it's on, make sure it's shooting the right image and verifying the image. Record an LDAR plan for each site. Well, you got to figure out how to do that. That's the new Appendix K rule. We'll show you the one-time setup, and then it's automated afterwards. Record a leak. Now with Appendix K, you got to capture 10 seconds of that video and tag it. We do that automatically. Record the repair. You got to 10 seconds of video and tag it, automatic. Reporting, it's manual, third party, and we provide that as well. Repair, it's manual on site. And I'm going to show you with autonomous LDAR, you can actually diagnose, detect, and fix most of the stuff remotely, meaning you can eliminate that windshield time. Distance, again, it varies depending on environmental conditions. And Craig, you said on your website, you might want to give that website where people can get maybe that matrix for the handheld on distance.
Yeah, we do have a matrix for operators that provides, the testing that we've done to try to help the operational industry understand the varying conditions from wind speed to delta T as it's addressed in Appendix K, to the distance that you can be with those two variables. If you go to FLIR.com/OGI, like optical gas imaging, there you'll see a link to an NPL report, which was the testing facility that we utilize to both confirm our technology's ability to meet the Quado A sensitivity metrics, but also we went above and beyond that, provided a matrix to help the industry in being able to understand how the product can be used while they are on site, if they simply just know the environmental conditions that are happening while they're there.
So with autonomous LDAR, we can see everything that the G300 sees, okay? But what we do is we sort of optimize it. And I was going to write a bunch of stuff here, but I'm actually show you because I think seeing is believing here. And then on quantification, you do have the FLIR QL320. I don't know if you want to mention what that is.
Yeah, we have a tablet that can either be attached to a FLIR camera while in the field for instantaneous quantification, or you can store files within a camera in the field and post-process. But it is a one event at a time. Camera needs to be on a tripod because to be able to quantify realistically, you're looking at changes in scenery and changes in intensity at a pixel level. So we do have a couple of different ways to do it, and it's all tied to the FLIR QL320 tablet that we have within our portfolio now.
Okay. Yeah. And so with our system, it's automated, 95% accuracy as confirmed by our clients with controlled blind testing. In addition, we've dealt with all the movement stuff. So we've literally used this in drones, and it can fly around and detect accurately, as well as quantify, even if the image is moving. Certified gas, this is something that we do now. It's not available on the manual LDAR, but we actually, with our system, can automate Standard & Poor's methane performance certificates, and then we all have our own blockchain energy certificate.